I am Jim Secosky. I'm a retired science teacher. I taught many different subjects, including astronomy, and my passion is just to learn and to explore. And I've always read a lot and done all sorts of things. I selected to use the Hubble Space Telescope as an amateur. I was the first one to do it for the study of asteroids, and then I did a second study on another topic, IO. And a number of years ago, after Mars Global Surveyor was almost near its end of its lifetime, they allowed amateurs to suggest topics. I went crazy with it. I submitted thousands of suggestions based on the Viking maps. And then 3 years ago, NASA allowed amateurs to use the People's Camera, the high-rise, the best camera ever put in orbit around Mars. And I went crazy again. I submitted thousands of requests, and I've gotten hundreds of pictures back from high-rise. And I want to share with you some of the geography and geology I've learned in the process. And you've probably never seen most of these pictures. Some of the basic ones you've seen. Now, I want to get into some of the geography. So I think a good way to approach geography of Mars is like the stars, the constellations. If you want to learn the constellations, it's overwhelming. But if you start with something big and bright, like the Big Dipper, easy to see, and then you work from there. You get the pointer stars and get the North Star, and then you go from there with the Little Dipper and so forth. With Mars, it's kind of overwhelming, so I want to go through some of the major geography things that an astronaut should know. You probably need to know a lot more than this, but what I present in the next 20 minutes is something you probably should know if you're going to be an astronaut on Mars. You might start with Citrus Major. It's a dark spot, and it's maybe the first thing you'll see as you're approaching Mars with your space station. And then you go to the left of it, you find Arabia, big desert, and to the right is Isis Peninsula. And those are major features. Arabia is an interesting place for a number of reasons. Geologically, it has many layers. You've probably seen some of the pictures with many layers on Mars, and they may have formed underneath a sea or a lake or an ocean. And there's a lot of those in Arabia. Arabia has enormous amounts of dust, maybe 20 meters of dust in places, so it makes strange formations. Isis Peninsula is probably an old ancient impact. So you get straight with Citrus Major, which found that over 300 years ago, easy to see, and then you move along. Down below it, you have Hellas Peninsula. It's the lowest place on Mars, and that's important because you'll have the greatest atmospheric pressure there. And so when people are there and we're starting to terraform things, and the oxygen levels are coming up, that'll be the first place you'll be able to walk around without much oxygen. And then at the bottom of Arabia, there's Chaparraldi. Now, that's an interesting place to know because it marks where the equator is. If you're looking at this side of the planet, the equator, the equator goes right, there it is. The equator goes right across the top of that. So the equator's right along here. So you want to find out where the equator is. And Chaparraldi is named after the father of Mars, the Italian astronomer. Chaparraldi, he came up with the word canale, which people shortened to canal, and then you know the story from there. And for about 10 years, he knew more about Mars than any living person on this planet. And he studied Mars, and he named things. So we have a very prominent crater named after him. Chaparraldi is also an interesting place. It has some layered features. Then on the other side of the planet, we have our well-known features. We have all these volcanoes. So this is on the Tharsis Rise. You have Olympus Mons, the tallest volcano. And then you have Elba Patiri. It's the largest volcano in area. And then you have these three volcanoes in a row. I like those. The middle one is important, Hermonus Mons. It is on the equator. So again, if you look on this side of the planet, you'll get an idea where the equator is. And if you go along here, And just go over to the right, to the east a little bit, and down, just south of the equator, is Valles Marineris, which we all know is a Grand Canyon on Mars. And some of the older people remember when we first got pictures back, we were looking at this interesting feature, Noctis labyrinthus. It's right at the start of Valles Marineris. And with my study, I've been looking for a lot of things, looking for glacier features, where's ice, where's possible water. And what I found is if you take these three volcanoes, and they're almost always visible, and they point down to here, and there's a lot of gullies down in this area, which probably the biggest discovery of our century is finding gullies, which may be recent, flowing water on Mars. Of course, you might have ice caps. They're visible both on the North Pole and the South Pole. They get small and they get large, just like on Earth here. Now this is your standard model, standard map we use. So if you're an astronaut going to Mars, you probably want to get used to looking at this and how they have the numbers. They basically have this set up with 0 down here, 0 longitude, someplace along in here. And of course we can review some of the things we've had before. We have Citrus Major. This is set up with altitude and depth. So the deepest we said was Ellis, impact crater. And then it's a dark color, and the highest, Olympus Mons, we said is white. So the highest things are white, the lowest things are like a dark blue. And you see a lot of features on this. You see our Valles Marineris is coming out pretty good. And we have another big impact here, Arjar. And then we keep talking about Elysium, there it is. That's a volcano. I guess it's named, it's a Greek land for the privileged. If you've worked hard, you get to go to a place where you have to worry about anything. It's a paradise. That's what, according to Greek legend. And Schiaparelli named it there. So you have the volcanoes. You have the major ones here, the Tharsis volcanoes. And then you have a few others scattered around. You have this set of 3 with Elysium there. And then you have a little one down there. This little one down here is pretty neat because that's where we landed one of the rovers. And we landed in this lake bed, but there wasn't any lake sediments. It was covered with lava. And we think that volcanic material came from that little volcano there. And I like this particular volcano here, Serenus Stolos. It gets no respect. It's so small and puny. It is higher than all the Rocky Mountains. All the mountains in Colorado, including Pikes Peak, is smaller than that. It's about 16,000 feet high. We brag about our 14,000 peaks here, and that little puny thing is bigger than the rest of them here. There's no credit though. Now, looking at this with the depth, you can see there's a difference. In the north, it's smooth and it's basically low. In the north, it's much higher and there's an awful lot of roughness to it, a lot of craters. So I found a lot of interesting things in this rough area here, and I studied a lot of this area here because there's a lot of glacial features. It's near the crater Lyot there. The low spots, the craters and other places probably contain lakes for a while, and one of the evidence of lakes are deltas. I get all excited when I got this picture of my delta here. So this background picture is a CTX image. So they have CTX images. They're very good. They go about 30 kilometers across, and you see things almost the size of this room here. So it has a resolution of 6 meters. So it has very good resolution here. So I looked at this picture this area here to examine with the high rise. And after a few months, I got this picture, which you can't see too much with the lighting here. But it is a delta. And deltas are formed by erosion taking material into streams and rivers. And when they go into a lake, they will deposit their material and have this sort of shape. And you sometimes, if you're lucky, you'll see little distributary channels in there to kind of confirm you have a delta. So I wanted to study that, and I sent in the information, and they took the picture, and it came back not as a study of a delta, it came back as a possible future landing site. So I was really excited. I may have found the future landing site. I'm just an amateur just like you. Anybody can submit these proposals for pictures. I just got lucky. I'm really happy here. Now, so this is the delta. So you probably had a lake here. This is the floor of the crater. This is the rim of the crater. And so basically what I did was I went through thousands of these CTX images, looking for features that might be interesting or strange. And I found a lot of neat things. Now, there's major outflow channels on Mars, and when we found these, it was unbelievable because for these to be formed, it would take a discharge equal to hundreds to thousands of times the discharge of the Amazon River. So when they found these outflow channels, they thought, man, there must have been water on Mars. Lots of water on Mars someday. Now you can see some of these outflow channels here, and there's a big one right here, and there's smaller ones around. And I want to focus on this area here next. And this is one of my pictures from high rise. Now the high rise pictures are 6 kilometers across. So basically, a lot of people run 5K races and 10K races. So probably most of us could walk across this landscape here. These pictures are so good that they use them to keep track of the rovers on Mars. They see the rovers on Mars. They actually see the tracks on Mars in those rovers. So these are good pictures. Now this is a source of some of the outflow channels. Some of the outflow channels, they seem to come from cracks in the ground. And some of these cracks, you have lava coming out first, and then you have water next. Sometimes you have water coming out, forming channels, and then lava comes out later on and covers it. We look at it with our instruments and we see nothing but lava. But usually a lot of water comes out first. And this is Servius Fossey. I guess the Science Fiction Channel has some movies sometimes about Servius, the dog of hell. And this is another place where some of the biggest outflow channels come from is chaos regions. In chaos regions, it seems like the ground has just collapsed and water has flown out. This is Arguin chaos, and it's named after gold. And like the Latin word for gold is Arguin. And gold, and down the road, everybody puts AU on their bumpers because it stands for gold, I guess. But and the theory for this is they think, and they're not sure, is over years, you had a lot of water on Mars, and then it froze into the ground. It formed a cap, a cryosphere. And then the cryosphere got thicker and thicker, and it got thicker and thicker on the bottom. And as it did this, it pressurized. So you end up with a whole lot of water underneath this real thick cap of ice. Then when something happened, like a meteor strike or maybe a nearby volcano, that would crack that shell and all this water go flowing out. We really don't know exactly, but that's some of the ideas here. This was my first picture I got from high rise. I was so excited with this picture. It's so excited to get these pictures from Mars. They're so neat. Some of them there's not much there, but some of them are really neat. Now, this is a map showing the landers we have had on Mars. And we've kind of stuck to the area near the equator because energetically it's much easier to get there. And we picked places that are flat and safe. And they also are often very boring. I was able to explore some really neat places. Now, I found it interesting that Viking 2 is by this crater, my crater there, right next to it. And our later research has shown that if Viking would have dug down 10 more centimeters, just a little bit, it would have struck ice. And that would have probably changed the history of exploration a little bit. And we know that Phoenix landed very far north, and Phoenix actually exposed ice when it landed. The landing rockets blew away some dust. Underneath the dust was a big slab of ice. So we did find ice with Phoenix, and Opportunity, with its explorations there, found evidence of small amounts of water in the past, and maybe small amounts of flowing water in the past, liquid water. Curiosity is in an interesting place there, and it has found evidence of pretty big streams. Streams maybe as high as your waist. That was one of the first things they found. So we probably should be familiar with where we've landed before, and we've had a lot of landings there. Things are pretty interesting. Now this is information from the Odyssey water experiment. It found the water in the dirt, the upper meter of the dirt, using a neutron spectrometer. So it was able to measure the amount of hydrogen, which is probably associated with water. So what it found was that the red would be a lot of water, and the blue not so much water, but still some water. And it's hard to see the map, but they're set up with 0 longitude in the middle. And if you strain your eyes, you might see those 3 volcanoes there in a row. And here's the Valles Marineris, and there's the Paradise, Elysium. Now right below there is where Curiosity is. So Curiosity is in a place where there's an above average amount of water in the soil, which is interesting. And then we have our, I can already see, Citrus majors here, and here's our Arabia. Now for some reason, Arabia has a whole lot of water in it. And Arabia is an interesting place. There's a lot of studies there. There's a fellow in Golden at the college there. He does a lot of research with groundwater. So it seems like there might be a lot of groundwater coming up in that area, but we still don't know. This is my picture I call the ice picture. It shows where ice-related things are often found. And these boxes find a lot of glacier features, paraglacial features between 30 and 60 degrees north and 30 and 60 degrees south. Of those, this area here is probably where you find way over half of the glaciers on Mars. And we call these areas Durnillus, Protonnillus, and Nillocyprus. So there's a lot of glacial features in those areas. We said there's a lot of gullies in this area. But the gullies are spread out all through this. They've done a lot of research with pretty much, okay, 10 minutes to go or 10 minutes to go? Okay. Minutes. Good, okay, thank you. I'm on schedule, thank you. Okay, so this shows the ice features, or a lot of ice features. And I found some interesting things all through here. Okay, now if you're an astronaut, hopefully you won't be distracted by things that are really pretty, but we understand them. So next couple slides are things that are really pretty. People said they're really pretty, but we sort of understand how they're formed. There's the dark streaks, dark dust streaks. They start out being dark, and then they get lighter with age. Recent research shows they last 40 years. They looked back to the Viking pictures, and they found that there was a whole bunch of these streaks 40 years ago. And look at the same spot today, we find the same number, but different ones. So they think the lifespan is about 40 years. What we think, and what most people agree now, is that what you have is avalanches of dust. Bright dust, very thin, but bright. And you get an avalanche of it. It starts going down, it keeps on going down, keeps on going down, and exposes the dark undersurface. So they're nothing to really examine too much, but they are pretty. They are very pretty. And then we have our sand dunes, dark sand dunes. They're found in many low areas, many craters. And this didn't come out to do this. It's pretty light in here, but These have been on the list for the prettiest pictures on Mars in history. We have taken hundreds and hundreds of thousands of pictures of Mars. When they ask people, what do you like the best? The sand dunes usually makes that list. So we don't want us to pay too much attention to them. They're just sand dunes. Then we have these dust devil tracks. So each one of these marks represents like a miniature tornado going by. And it blows away the bright dust and exposes the dark undersurface. So you have these dark streaks. And they last for a while, and then they change. They get erased. Like if you have old-fashioned, used to have these blackboards. Some of you old enough to remember me went to school, you have blackboards, and you'd erase the blackboard and start all new. And that's how this is. New dust comes on, it erases everything. These also made the cut for the most magnificent pictures in history of Mars. But we understand what caused it. We have seen them on the ground and from orbit. They're kind of small, maybe a couple hundred meters across, but they're very tall, several kilometers high, so we see the shadows. So from orbit we see them, and we make movies of them going by. Now, then there's another group of things we really should know. If you're an astronaut going to Mars, you should know about these because you might have to walk up to these things and check them out. Get rock samples or drill into them or focus a penetrator on these things because they might contain a whole lot of water ice concentrated. And when you're a colonist on Mars, you want to know where the water is. Just like when people came across the country in their Conestoga wagons, they had to know where the water was. You go to Mars, you got to find out where the water is. And we have theories and ideas that suggest that these are probably areas with a lot of water, but we have to check it out. So we have the ring-molded craters here. Sorry about this. What was the name? Okay, here's this Mars. So they're called ring-molded craters because they have the shape of a ring mold baking thing. And they often have no ejecta. And there's evidence to suggest that they contain a core of ice, and be pure ice. So that'd be a thing to investigate. Our knowledge of impact cratering allows us to understand these a little more. We think there's some areas where you have, this didn't show up, you have a layer of dust and dirt on top of a layer of almost pure ice. And when an asteroid comes down and strikes it, it makes a crater. If it penetrates the dirt's on top, you can't see here, if it penetrates the dirt, then you'll get a rebound effect and form that ring mold. And what's coming out, a lot of what's coming out is ice, and it will disappear kind of quickly, so you often will not have the ejecta. Now, note if you have a, you can't see it all here, just add something else. Now, another thing, I like this stuff that's really interesting to look at here, it's brain terrain. And it's found in many areas on Mars, and you have the closed cell brain terrain with these thick ridges, and you have open cell brain terrain with thinner ridges. Here's a size of a football field. You have an idea how big they are. It's thought that the closed cell brain terrain has a core of ice, and when that ice disappears, then it collapses. The middle part collapses, and then you get open cell brain terrain. And there's a lot of this around, and maybe there's life forms connected there. It's been around for a while, probably. Now, this is one of the more interesting things they keep getting to, pingos. Now, what a pingo is something with a core of ice. So you once had a lake there, and then the lake water went down into the ground, and then it started to freeze. Then it got pressurized, and you had a ball of pure water, pretty much. And what we think here is you have a big chunk of ice in there, and it's covered with a layer of dirt. So this might be a good place to, in the future, have robot spacecraft go there and dig through the top and then load up the ice for you. There's the size of a football field. The pingos are round or maybe oval in shape, and they have cracks on top. So this is a possible pingo, but they look like this. This is another thing, we're looking for these, but you can only see so much from orbit. Some of these things you have to go there, and perhaps we'll send penetrators down on this. Back in '98, we designed penetrators to go down into fall from orbit, go down and look for water. The gullies are really the biggest news around. They're found on steep slopes, and there's a gully in here we can't see with the lighting. And sometimes they're single, not too often. And on steep slopes, usually craters. Here's a Martian. They have usually three parts: the alcove, channel, and apron. They were discovered in around 2000 with the Mars Global Surveyor. And most people today agree they probably involve running water, and relatively recent, maybe a million years or so. A million years isn't very old on Mars. The southern part of Mars is probably billions of years old. And this would probably be a good place to look for life, because you may have had water over a long period of time there intermittently. And it doesn't take too much water to make these, they've found. Many places on Mars go above the freezing point of Mars for a couple hours every day for a couple months. And all you need is a couple hours, a little bit of water coming down, and it gradually forms these. Sometimes they're in big groups, and down at the bottom, you see these ridges, and they're probably from glaciers. It may be that you first get a lot of glaciers, and they leave their moraine and debris behind, and then later on, the gullies develop. And I have just a couple more slides to go here. I didn't know about the lighting here, it's kind of bad. This is polygonal terrain. This is the low center polygonal terrain. It has a low center and a high ridge on the outside. And on Earth, these are found in frozen ground. So we see these on Mars, and probably it's frozen ground. They have these in about an hour or 2 hour drive from here in Rocky Mountain National Park. This is another kind of polygonal terrain, and again, these are associated with frozen ground, and some people think there was melting involved sometimes for this. So those are good places for life, maybe. And so, in summary, these are the things you probably want to know what they look like and be able to examine them closely. Some of them may be sources of water for colonists, and some of them might be where you might look for past or present life. And the biggest news is the gullies there. So thank you very much.
So if you had to pick now, what's your top suspect site for a colony lander?
Site for colony?
Especially if you're interested in definitely baking water out.
I don't know. I would want to be sort of close to these features, but I'm leaning towards developing robotic craft, not craft, but like a robotic bulldozer to go and dig up the ice and then haul it back to where you're living. Because you have these huge deposits of ice, and you have to weigh everything. But luckily, I think we can map all this stuff from orbit, so we'll know exactly where they are. I don't know if I answered the question. Yes?
How does one go about requesting photographs?
Just go to the high-rise site and go under HiWish program, or just type in on your search engine HiWish, and it would come up and it gives you the directions to submit things. And you have to have some patience when you submit, and when anybody submits things, it takes a couple months to get everything working. So you submit the proposals, and then maybe a couple months later you get it. Whether you're an amateur or a professional, it takes time for all that. But after a while you get it going, it's exciting. You just sort of get a time delay in your head. Yes, sir?
When you're talking about elevation, what is that measured with respect to? There's no ocean.
Okay, they decided to come up with a 0 point. And I forget the exact way they do it, but one way of thinking about it is getting the highest altitude and the lowest altitude, get in the middle. But they arrived at some elevation is going to be 0. Yes, sir?
In the lowest point, the Hellas Plantea, is it substantially low enough that the atmospheric pressure is actually greater even today? Is it like 2 millibars versus 1 millibar? Or?
think the atmospheric pressure might be an average around 6 on the planet, and in Hellas it might be 8 or 10 maybe. So it's a much higher. It's a little deep. Yes.
Yes, do those photos show any recent volcanic activity on Mars?
No, we haven't found any recent volcanic activity. That's a good question. We have found a lot of activity. The dust devils will change. They've found ripple change in the sand dunes. I think they even found some sand dunes moving. They found gullies, changes in the gullies, and the change in the gullies they may be because of landslides, they may be because of something else. But when I go to when I get the pictures and I go to submit things, a large proportion of the pictures that are taken with high-rise are repeat observations of the same thing. They're looking for changes, and they are finding changes. It's a big deal because we've had this going for a lot of years now. So we're finding a lot of discoveries by looking at the same thing over and over again.
Sure. Thank you.
Yes, sir.
I've looked at a globe of Mars, and on one side is the Hellas Basin. On the almost exact opposite side of the planet is Valles Marineris and the Tharsis volcanoes. It leaves me wondering if the Hellas Basin didn't sustain an enormous impact that literally cracked the crust on the other side of the planet.
Some people say that, and I looked a lot into some areas on opposite parts of the planet. There's a whole lot around Hellas that are, some researchers say that very thing. There's no 100% certainty, but some people do believe that, and they're still looking for evidence. You have that going on Mercury. You have certain things on one side, opposite side of the planet, you have something else. So if you use physics, geophysics, it is probable. Yes. But you guys are really on the ball on these questions. They're deep. Yes, we're done. Thank you.